We're going to go ahead and do simplifying radicals and then multiplying radicals. This is Algebra 2 Semester 2 Unit 2, first section 2-1. To start, if you have a factor sheet, is that the first 100 factors? The factors of the first 100 numbers. Um, if you don't have that, let me know and I can send it to you. Otherwise, we can just do it the old-fashioned way. So I'm going to start with square root of 12. How do I simplify square root of 12? What I'm going to do is I'm going to find all the factors of 12. So that's where the factor sheet comes into play. So it's 1 times 12, 2 times 6, and then 3 times 4. Now what I'm looking for, now generally what I can do is the square root of 12. I can leave it as the square root of 12. I can make it square root of 2 times the square root of 6. That's equivalent, that's true. Or the square root of 3 times the square root of 4. So these are all factors. So with that in mind, I can just then put square roots over top of them, make a multiplication, and they are equivalent to that square root of 12. Now, what I'm going to use to simplify would be the 4. Why am I choosing the 4? Because it is a perfect square. Alright, so what I can do is the square root of 4 is 2. So the square root of 12 simplifies to be 2 times the square root of 3. If I go over to 50, again, I got to find all the factors of 50. So I have 1 and 50, 2 and 25, 3, 4, 5, and 10. I think that might be it. We'll leave it there. I'm looking for my biggest perfect square. Well, that's going to be 25. Not a bad idea to go ahead and list all your perfect squares. So we have square root of 25 times square root of 2. Square root of 25 is 5. Square root of 2. And I'm done. Square root of 50 reduces down to 5 times square root of 2. Come over here, we can do the same thing with 45. What are all the factors of 45? 1 and 45. 2 ain't gonna work. 3 and what, 15? 4 and, I don't know, what, 5 and, oh, excuse me, what's that gonna be, 9? 6 isn't gonna work. Cool. So I'm looking here, what's my, so square root of 45, I could have done square root of 3 times square root of 15, square root of 5 times square root of 9. I'm gonna go ahead and choose the one with the 9 because it is a perfect square. So this is going to be square root of 9 times square root of 5. 3. Oop, better. So square root of 45 reduces down to 3 times the square root of 5. This is the answer I prefer. However, Apex is going to ask you to do a couple different things. We'll get to that here in a second. Now, how do I solve this? Alright, cool. So now I'm given a square root of 3 times square root of 15. How would I solve this? Like, how would I simplify this? What I'm going to do is I'm going to get into one square root. I'm going to do 3 times 15, which is 45. And then I had the square root of 45. And then I would solve this problem. Alright? Well, we already solved this problem over there. But the strategy here, if I'm given two different ones, I just go ahead and I multiply them together. 6 times 10, so I'm just going to change this to square root of 60. Now, how do I simplify the square root of 60? Just like I've done all the way, it's going to be 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think that one's going to be it. So if I'm going through all these numbers, what is my biggest perfect square? Well, in this case, it's only going to be a 4. So I can change this to square root of 4 times square root of 15. This will be 2 times radical 15. Now, there are some questions asking which are all equivalent. Well, square root of 60 or square root of 2 times square root of 30. If I put square roots around all of these and make them all multiplication, they would all be equivalent to the square root of 60. That's one thing we want to look out for. It's like, if we have multiple choice, all of these with a square root is equivalent to that 60. So just remember the square root, and you could say they're all equivalent. But I prefer the simple version, which is 2 times square root of 15. Apex sometimes asks for more. Alright, so now we have 3 radicals. Uh-oh, is this going to be different? Not really. It's going to be the same idea. I'm just going to do 2 times 6 is 12. 12 times 3 is 36. Now 36 is a perfect square. Hopefully that jumps out at you. That's something that you know. The square root of 36 is 6 and I'm done. But again, even though it was 3, I'm still just multiplying through. Now this next one, it's a little bit different. I have a whole number. Well, how do I do this? Well, what I'm going to do is I'm going to take this 6, the whole number, and I'm going to square it. And I have square root of 2. Well, 6 squared is 36. But to make this equivalent, because 36 is not equivalent to 6, and squaring it isn't just allowed. I can't just square the 6. So, but what I can do is I can make this a square root of 36. Because what is the square root of 36? It is 6. So 6 and the square root of 36 are equivalent statements, or equivalent terms. So I can make that change. Now I have two radicals. Now I can multiply 36 and 2 is going to do the square root of 72. Now this was a problem that's on your study guide that's asking for multiple answers. So what we would do is I would again just find the factors. So 1 times 72, we already have 2 and 36. 3 is going to work. 3 and 24, I think. 24, 48. Yep. 4. I think 4 works. 4 and 8. 4 and 18, I mean. 5 isn't going to work. 6. 7 not going to work. 8. I don't think so. 9, 10, 11. Nope. Cool. So when I'm looking at my apex answers, these are all the possibles here. So if I put square roots over all of these, all the way down, and multiply them together, they would be equivalent. Now one thing to note here is 4 is a perfect square. So what they could do is they could change this one and say this is 2 square root of 18. They could say that if they wanted to. It's not simplified, but they could say it. So for these, you take the whole number square, you put it under a radical, get it back into one number, get all the factors, and then you're just looking at your answers to see which ones matches up. These are all the possible answers. You just have to remember that they have square roots over them. All right, the only time we can get rid of a square root is if we actually do the square root. The square root of 4 is 2. That means we can get rid of the square root. We're good. All right, 4 times 50, it's going to be 200. And then we're going to find all the factors of 200. I guess I should have checked this before I signed up for it. 1 and 200, 2 and 100. 3 isn't going to work. 4. I don't think 4 works. I'm doing this all in my head. I should have prepared. What am I talking about? 4 works. 4 is 50. We just did it. See? Brain farts early in the morning. 200. So we got 5 and 40. I don't think 6 is going to work. I don't think 7 is working. I don't think 8's working. Well, actually 8 works. 8 and 25. Cool. 10 and 20. I don't think 11's going to work. I don't think 12's working. 15 maybe? Nope, 15 doesn't. I think we are done. I think that's it. Alright, so these are all the factors of 20. Again, I can put all these over square roots and multiply them. Now, and they would all be answers. Now here, I can make this 10 times radical 2 because the square root of 100 is 10. Here, I could make 2 radical 50 because square root of 4 is 2. Here, I could make 5 radical 8 because square root of 25 is 5. So we have the option to actually operate on the square root, or we could just leave these all radical 5 times radical 40 because it equals your radical 200. They are equivalent.